In this video, we're going to look at questions number 38 through 41 from your final exam review. These questions are about arithmetic and geometric sequences and series, and it might be helpful for you to have the formulas there in front of you, your sequence and series foldable, just to have those formulas to reference as we go through these questions. Question number 38, it says, given the sequence 10, 7, 4, 1, find a sub 25. Now remember, this a sub 25, that means to find the 25th term in that sequence. And to do that, the first thing that we need to do is to determine what type of sequence this is. I can see that we're subtracting 3, or if you want to think about it as adding negative 3 every time to get the next term. And so that means that this is an arithmetic sequence. It's arithmetic. And we're going to say that the common difference is equal to negative 3. To find the nth term of an arithmetic sequence, if you're looking at your formulas, you'll see the formula a sub n is equal to a sub 1 plus d times n minus 1. That means that we're going to take the first term and then we're going to add to it the common difference n minus 1 times. So a sub 25 is equal to a sub 1, which means the first term, that's 10, plus the common difference, which is negative 3, times 25 minus 1. And that is equal to negative 62. Let's look at the next question. This time we have the sequence 4/5, 6/10, 9/20, 27/80, and we want to find the 9th term. So first of all, we need to determine what kind of sequence this is. It doesn't seem like we're adding the same thing every time, and so it's probably a geometric series. Looks like we're multiplying by something every time. And in this particular sequence, it's kind of hard to tell what the common ratio is. Anytime that you can't tell what the common ratio is, the way that you can figure it out is by choosing a term. I'm going to choose 6/10 and then divide it by the previous term, 4/5. Because a common ratio is what we're multiplying by to get the next term. And so in order to figure out what that is, I can pick a term and divide by the one before, and of course that would tell me what I multiplied by. That'll give me the common ratio. So I'm dividing fractions, and so I'm going to multiply by the reciprocal, 6/10 times 5/4. And that would multiply out to be 30 over 40. And so it looks like my common ratio is 3/4. Common ratio of 3/4. So now we're ready to find that 9th term. For geometric sequences, the nth term is equal to the first term times the common ratio to the n minus 1 power. So in this case, a sub 9 would be equal to a sub 1, which was 4/5, times the common ratio, which we just figured out is 3/4, raised to the 9 minus 1 power. And then if you put all of that into your calculator, it's going to give you the fraction 6,561 over 81,920, which is approximately equal to 0.08009. And so that would be the 9th term of that sequence. In the next one, question 40, the new MIU Arena has 24 rows of seats in the upper level. The first row has 180 seats, the second row has 184 seats, and the next row has 188. If this pattern continues, calculate the seating capacity of the upper level. So my sequence here is 180, 184, 188, and so on. So we're adding 4 every time. We're adding 4 seats in every row. So we have an arithmetic sequence here. And we want to find the seating capacity, which means I want to add up all of the rows of seats in the upper level to find out the total number of seats. So if I look at my formula for summing an arithmetic sequence, the sum is equal to n divided by 2 times a sub 1 plus a sub n. And so in this case, I know the number of rows, which is 24. And I know the first term, which is 180, but I don't know the last term. I need to figure out how many seats are in the last row. And so we're going to go back to that formula we used in a previous question. A sub n is equal to a sub 1, the first term, plus the common difference times n minus 1. And in this case, since we have 24 rows of seats, I want to find a sub 24. So that's going to be equal to the first term, which is 180, plus the common difference, which is 4, times 24 minus 1. And then if we put all that in to the calculator, we're going to get 272 for a sub 24. So now I can go back to my sum formula. We've got all the information we need for this now. The sum of the 24 rows is going to be equal to 24 divided by 2 times the first term, which is 180, plus the 24th term, which we just figured out is 272. And then we can put all of that in the calculator, and we get that there are 5,424 seats in the upper level of the arena. All right, last question in this section. Express the following series using sigma notation, then evaluate the partial sum. So sigma notation, that's when we used this guy to represent a sum of a series. And so here, if I look at what I have in front of me here, I've got 1, 2, 3, 4, 5, 6 terms. And so we're going to sum up starting at term 1 and stopping at term 6. And then I need to come up with some expression that represents each of the terms that are shown here. So if I look, I'm starting at 4, and then 2, and then 1, 1/2, 1/4, 1/8. So this is a geometric sequence, and our common ratio here is 1/2. The terms are being cut in half every time. We're multiplying by 1/2. And so a simple way to set up this summation notation is just to use the a sub n formula for geometric sequences. A sub n is equal to the first term times the common ratio to the n minus 1 power. And so if I transfer that over here to the sigma notation, it's going to be the first term, which is 4 times 1/2 to the n minus 1 power. Another acceptable summation notation for this problem would be you could start at 0 and go to 5 instead of doing 1 to 6. And then in that case, our expression here would be 4 times 1/2 to the n. Either one of those would be acceptable, and they are both equal to 63/8, which is approximately equal to 7.875.